Hi, I'm Nurul Fakira Afsa, and I'm here to explain about our objective of our investigation and also a little bit information of our failure material. So the objective of this investigation is to reveal the environmental suitability of duplex stainless steel coiled tubing in oil and gas well environments. Various tests such as electrochemical tests, high temperature and pressure corrosion tests, stress corrosion cracking tests were applied to observe and analyze the corrosion product. So the failure material used in this investigation is the duplex 2205 stainless steel, which is a two-phase structure consists of 50% austenite and 50% ferrite, and it also consists of 22% chromium, 3% molybdenum, and 5 to 6% nickel. As we can see, it has the highest percentage of chromium, which is 22%, and due to this high percentage of chromium, it demonstrates superior corrosion-resistant properties in most environments. And other than that, it also provides high resistance to pitting and crack corrosion. However, it is not recommended to be used in any application above 300 degrees Celsius because somehow it will be subjected to embrittlement. In addition, its properties leading it to be used often in application which requires high pressure and processing environment. For example, it has been widely used in industry for chemical processing, transportation, and also oil and gas exploration.
Hi, my name is Aiman Sofia. So we go to the background of the material. Failure is related to the high temperature and high pressure. So for the method to analyze failure is stress corrosion test, stand as SCC test. In the production environment containing CO2, carbon dioxide, and the hydrogen sulfide, this SCC test sensitivity of 2205 duplex stainless steels need to be further evaluated under high temperature and high pressure condition. This SCT test in production environment was conducted by 4 bending point loading method with loading stress of 496.8 megapascal. Then the loaded samples were put in a high temperature and high pressure autoclave for testing. Then the test conditions, including the test solution, carbon dioxide and hydrogen sulfide, partial pressure, total pressure, and test time, same as the corrosion weight loss test in production environment at a certain amount. So after the SCC test, the longitudinal sectional morphology of maximum stress area of the sample was observed by optical microscope and scanning electron microscope.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal, and for my part, I will explain to you about the result of the method that we have analyzed, which is stress corrosion cracking. And through the stress corrosion cracking test, which is simulated with the formation of water containing H2S and CO2, it is found that the sample have no macroscopic cracking characteristic, but obviously the corrosion pits can be observed on the surface of the samples. The longitudinal sectional analysis of the stress corrosion cracking sample shows that no cracking features are found, and the high magnification SAM, which is scanning electromicroscopic image, further shows that no cracking has occurred at the bottom of the corrosion pit, which indicates that the 2005 duplex stainless steel has excellent stress corrosion cracking resistance in the simulated formation of water that containing H2S and CO2. That's all for me. Thank you.
Okay, now we are in the result part. So there are certain tests has been obtained in the study. So which is the weight loss test, firstly, second the electrochemical test, third is stress corrosion cracking test, and SEM test, XRD test, and finally EDS test. For on the left hand side, we can see a table on there. So which is the corrosion weight loss tests were conducted in acidizing and production environments. So results show a good corrosion resistance in both environment with the main product which is iron sulfate and iron carbonate. So it's being the main product. So 2205 duplex stainless steel exhibit the lower corrosion rate in the production environment. Secondly, is the electrochemical test show that the higher pH value improves the corrosion resistance in the weak alkaline environment. So with the larger peak value indicating enhance the passivation ability of the protective film. This lead to a reduction in the passivation film dissolution rate and enhance the corrosion resistance in 2205 duplex stainless steel. And that one is the SEC test on 2205 duplex stainless steel show to the microscopic cracking but visible corrosion peaks on the surface. We can see on the which I attached the picture on the poster, which is laboratory sectional analysis and high magnification SEM images confirm no cracking. So 2205 duplex stainless steel show an excellent resistance to the stress corrosion cracking in simulated. Okay, continuously we are in the SEM test. SEM images show the corrosion peaks on 2205 duplex stainless steel dampers in the simulated formation, water with hydrogen sulfate and carbon dioxide, but no cracking. So high magnification SEM confirmed that no cracking at the bottom. For the XRD analysis was conducted to identify the corrosion product on the surface of the coupon testers in the production environment. The results show that the main corrosion production were iron sulfate and iron carbonate. So these are the XRD results that we obtained. And finally the EDS analysis identified the iron sulfate and iron carbonate are the main corrosion products in the production environment, which is hydrogen sulfate and carbon dioxide contribute to the formation of the protective layer and changing the stainless steel corrosion resistance. So let's move to the next part.
In this study, there are a few suggestions made to overcome this problem. Steps must be taken to stop the problem. Firstly, in terms of material selection, we need to consider the operating environment, fluid composition, and anticipated stresses. Duplex stainless steel is often preferred for its excellent corrosion resistance and cost effectiveness, but alternative material or coating could be evaluated for specific conditions. Secondly, corrosion inhibition through the use of appropriate chemical compound can form a protective layer on the tubing surface. This can help to reduce the rate of corrosion. The coating need to be chosen while taking into the consideration of corrosive species, operating environment, and the impact to the environment around us. Operational parameters such as fluid composition, flow rate, velocities can be optimized to minimize the erosion corrosion effects. We need to monitor and control the pH level and temperatures, implement proper fluid treatment to prevent the corrosion. This measure can ensure the longevity and safety of the coil tubing in the oil and gas operations. Today, I would like to talk about the root cause of failure in 2205 duplex stainless steel coil tubing. The increasing demand of oil and gas resources has led to the development of high pressure and high temperature wells. These wells are characterized by harsh working conditions such as elevated temperatures, high pressure, highly materialized formation of water, and the presence of corrosive gases like carbon dioxide and hydrogen sulfide. The combination of these factors creates an aggressive environment that accelerates the corrosion process. High temperature and pressure can enhance the reactivity of corrosive species, while highly mineralized formation water introduces additional corrosive ions such as carbon dioxide and hydrogen sulfide gases, commonly found in oil and gas reservoirs. Additionally, acidizing operations, which involve the uses of corrosive acid to enhance production, introduce a highly corrosive environment that poses a significant threat to the integrity of the tubing strings. And all these factors such as high temperature, high pressure, high concentration of corrosive gases such as carbon dioxide and hydrogen sulfide, and also the oxidizing environment of process can cause the duplex stainless steel to come to failure.